Yeah. He's got the mic.
Are you all set?
All right, guys. So we'll do our own intros just for the sake of time. We've called this thing 3 different things. When we did this talk in Vegas, it was how to hide your porn. When Orlando did it up at Rochester Security Summit, he called it hiding from Big Brother using distributed steganography. So this was the latest slide deck, and here I guess we're calling it a new technique in data exfiltration and confidentiality. That's a very long title, so we're going to go with this one. So, maybe, might work? No. All right. It would help if I put batteries in there.
Oh, okay.
So, who I am? I'm Orlando Barrera II. I have some security exploits, some vulnerabilities, Yalkeris, and 0 days. Basically, started as a code monkey. I'm working as a security analyst, NSS Labs now, doing exploit toolkits, malware, so reverse engineering, things like that. And I have some open source vulnerability database stuff up there. So I'm Josh Sokol. I am the LASCON co-chair. I am the Austin OWASP president. What else? I like to talk about security. More importantly, I like to learn about security. So for me, this was just a fun project. And as a disclaimer, my company does not endorse this talk. I'm not even going to mention the name of my company. If you're going to write about the talk, keep the name of my company out of it. So, all right. So, project beginnings. We do these Austin Security Professional happy hours every single month. We sit down, we talk about really weird stuff, and at this one earlier in the year, we happened to be talking about hiding porn. How that came up, I have no idea, but Orlando and I started talking, and somehow we brought up hiding porn at Austin B-Sides, and we started talking about how you would go about doing it with steganography, and by the next morning, Orlando had basically written the base of what's now known as Stego. So, this was a quote when we did this at B-Sides Las Vegas. Chris Nickerson was the organizer of the conference, and he said in his podcast, he actually said, Exotic Library Podcast, "Fuck yeah, internet is awesome. Why? Because it gets you your porn." So I thought it was a very apt quote for this presentation. So what is porn? For us, it's different for different people. What we're considering porn in this talk is data that's worth holding on to, or any data that's worth protecting and hiding. So that's what we consider porn in this talk. All right, so how not to hide your porn? I'll let you go over this. So these are some things that work fairly well, but there are things that there are countermeasures against, ways that people can detect this, whatnot. So the first thing is hidden files and directories, right? And if you're in Windows, there might be this little hidden guy, and when you click it, you don't see the file in the directory, and yay, mom doesn't find it, right? Unfortunately, there are plenty of ways to list out that. There's a dir command with a flag that can actually show these files in those directories. So if you're trying to hide from mom, this is fine. If you're trying to hide it from anybody else, probably not good. So the second thing you can do is rename the file or extension. This is more of an obfuscation technique than anything else, but if I have a JPEG and I rename it to a PDF, then nobody's none the wiser unless if I name it something weird, like horse something.pdf. So the other thing that you can do is, just like ET, hide it with something else, right? So you have a big directory full of images, maybe it's a video editing program or Adobe or something like that. Lots of images in there naturally, so you stick your files in with everything else and nobody finds it. Again, this will probably hide it from mom and dad or whatever, but it won't hide it from law enforcement or something like that. You can bury it several directories down. This was on the internet. Again, why this is on the internet, I have no idea. Like Nickerson said, the internet is awesome. Why? Yeah. So anyways, you can bury it several directories down, right? And this was a trick I used when I was a kid and didn't want my parents to find stuff that I had. I'd create a directory and then create several subdirectories. And I created like weird passwords based out of directories and whatnot. It worked great until Find came out and they were able to search and find that kind of stuff. So you can place it with other files in compressed format. Usually Find won't find it because Find doesn't search these zip files. But if you go and compress it, stick it in a zip file, it makes it a little bit harder, right? Somebody has to find the right zip file, open it, know what they're looking for, whatnot. Alternate data streams is a really cool feature. You find it in Windows. You can basically create a file, like this setupaccount.log, and then you can create what's called an alternate data stream. So we have that original file, and then we create this alternate data stream that basically appends to that file some level of data. This works very well, and if you do a DIR or something like that, or directory listing, this doesn't come up. The problem is, if you know the right flag, like this /r flag, then it does come up. So it only works in certain cases, right? Spam Mimic. This was something that I found when I was digging in and doing the research for this guy. So Spam Mimic is really, really cool. What it does is you put in a message, right? And in my message, I put the password is prawn. What happens is Spam Mimic takes that message, it encodes it in this crazy email that looks exactly like spam. You take that message, you send it to somebody, and anybody monitoring their email is none the wiser, right? It looks like spam. I can't find the password in here, I can't find prawn in here, I can't find any of that stuff when looking through this, but somehow Spam Mimic actually knows how to format that, and it'll take that, right here's the encoding, it'll take that and put it back to the decode form. So if you know, if Orlando and I are exchanging messages back and forth, we can put our messages in a spam, send it back and forth, and nobody knows what's going on there. Hidden partitions, so you can actually create a partition in your file system that nobody sees. Well, that's really good, right? I can hide stuff on there. I can make it so that nobody sees it. It's a hidden partition. And then you basically unhide it when you're ready to go and do something there. So another way to hide stuff. Very similar, invisible partitions. Slightly different way to create this, but the same general concept, right? We're creating a partition that nobody can see. Slack space. This is really cool. So when you create a file, what ends up happening on the file system is it allocates a sector or multiple sectors for that file. And when it allocates that sector, your file only uses some of that space. So in this case, our data takes up 1, 2, 3, 4, 5, 6, 7 sectors, right? Almost 7 sectors. And what we do with Slack space, or in this case there's a program called Slacker, is we take this Slack space and that's where we put the stuff that we're trying to hide. We insert it into the Slack space and then we use our Slacker program and we can pull it back out of the Slack space when we're actually ready to use it. So another very cool way to hide it, and this is something that even more advanced things like law enforcement and whatnot, sometimes they're not even going to be able to find this kind of thing. Very similarly, you can actually tag blocks on your hard drive as bad blocks. The nice thing here is the disk won't use it. It won't overwrite the data that's in the bad blocks. So by tagging it as bad blocks, you now have a secret partition that the disk will never touch. So if you want to hide files in a sector labeled bad block, right, nobody will ever find the stuff in there. Anybody else have any other bad porn hiding ideas? Yeah? All right. Cool. So let's talk about stuff that works. I was at a conference, the Misty InfoSec World Conference. I was presenting out there, and there was this guy, and his name is Lance Hawk. He's this big-time investigator, right? He likes to do forensics, knows all about that stuff. And what he said kind of struck me. It was, the presence of encryption provides reasonable suspicion. So what does that tell me? Encryption is historically the thing that we rely on as security professionals to protect us, to protect our data, right? We encrypt our files, that way nobody sees it. Well, if you have files that are encrypted and some law enforcement agency comes along and sees that you have encryption, they have reasonable suspicion. They know that there's something on there that you're trying to protect. So as security professionals, if you're trying to protect that thing, encrypting it just says, hey, I have something to protect, right? And then it's between you and the courts as to whether they force you to enter your password and decrypt it. Which brings us to here, right? The FBI, the CIA, the law enforcement agencies, they know about this, right? And they've even said that having encryption is huge. They like encryption. They want to be able to use encryption for themselves. But when it comes to you guys using encryption, they don't want that because then they're not able to see what you're doing, right? So, here's a quote.
Well, this is actually really interesting. I don't know if you are familiar. There's a case right now. The EFS is taking it on. There's this lady that was involved in a mortgage scam, and her laptop is encrypted with, TrueCrypt or something like that. Well, anyhow, the State Department or the Justice Department cannot prosecute her without decrypting the laptop. So they're trying to set precedents and force her to decrypt her laptop so they can prosecute her. So this case actually does go through and they force her to decrypt it. It can set precedents for anybody that has encryption and is using that. And like Josh said before, just presence of encryption, if you have TrueCrypt or any other encryption algorithm, is cause for reasonable suspicion. And as you see here, the U.S. Department is actually saying that, it impedes their ability to collect evidence and prosecute this lady, basically. So, yeah, question? So the comment was, if you are forced to decrypt your encryption, then it's self-incrimination, I guess, the fifth, right. And that, like I said, is in case right now, and the EFF is working on it, so I think it's pretty important that we, as security professionals, stay abreast on these cases. And yes, another question. Well, that, to a certain extent, yeah. Yeah, I'm not sure that might be, you want to comment on that?
Yeah, so you're absolutely right? The idea here is when it comes to a court case, right, somebody trying to say you did something naughty, what they're saying is the fact that you're even encrypting data says that you have something to hide. Now, when it comes down to HIPAA or things like that, where you're required to hide the data, you may have a point. If you're encrypting data because you're legally compelled to encrypt the data, with PCI or HIPAA or something like that, then it might make sense. Really, what they're talking about in this particular case is we have a woman who really should not have been encrypting data by their standards, right? She obviously had something to hide. She was already part of this other crime, this mortgage scam, and so they felt like in order to obtain the evidence that they needed to convict her, they needed to unencrypt her thing. And so they're trying to force her to enter her password to do this, and like Orlando said, EFF is adamantly fighting against this for exactly the reasons Dee Dee brought up, Fifth Amendment and whatnot. The problem is, if the encryption is there, people are looking at, they know you have something to hide, right? So the remainder of this talk is really about how do you make it so that the encryption is there, but they don't know that the encryption is there. Cool. All right. So, I found this cartoon. I thought that this was really great. It's really telling, because what they're basically saying is, as a crypto node, you're looking at this stuff and you're saying, man, I got this super awesome laptop, I have TrueCrypt on it, all my stuff is super awesomely encrypted, nobody is ever going to get at this data, right? And the reality is, somebody's going to come up to him, drug him, hit him with a $5 wrench, and he's going to tell us the password, right? They're going to torture you, they're going to force you, the law is going to come after you, they're going to make it a living hell until you enter that password. And so we do see some things coming out with like TrueCrypt, and they actually have multiple volumes. So you have like the fake password that gets them at the stuff that you want to tell them that you're protecting, but it's not really illegal. And then you have the real password that has the other stuff, right? So we start to see these things, and this is the reason why, right? You don't want somebody to compel you to enter the password to make your life horrible until you do that. Anybody know what's hiding in this picture? Yeah? All right. So I found this picture on the web. It was actually really cool. This person had actually hidden this graphic within this graphic, this text within this graphic right here. And this is steganography, right? And that's kind of what Orlando based this on. Steganography is awesome, right? Steganography is the ability to hide something within an image, or within a movie, or within something else. Very, very cool technique. And we got to thinking, what if you could do steganography and encryption at the same time? That's a very, very powerful combination. That same guy that I told you about before, Lance Hawk, he also said this: the cases I've lost, I've been able to detect steganography, but not break it. So this guy, this very seasoned investigator, this guy who's looking for child porn cases and things like that, he says that he does an investigation, he finds steganography. He's able to see that the file isn't quite what the file is, but he's never able to break the stega. And especially if the file is encrypted, he's not able to do that. Which says to me, hey, this is some good stuff. As a security professional, if I'm trying to really hide this from somebody else, this is something that I should be paying attention to. So, the problem is, terror organizations, Osama bin Laden, they know about this too, right? They've actually been using this for years and years. Encryption plus steganography equals awesomeness, right? You can quote me on that. Basically, if you can take a file, if you can encrypt it, and then stego it, throw it up on the web somewhere, you can exchange messages back and forth confidentiality. And that's exactly what these guys have done. They've been using chat boards and things like that, uploading files, exchanging messages, nobody's the wiser. All right, so I think this is you.
So, doing our project, we didn't really do any background research. After we coded everything and started looking at it, we found that there is some other projects out there that kind of take this concept. This is by no means a complete list, but there are some cool applications projects that are being done right now. We just want to give attribution to those as well. Next slide. So, a new concept for data protection and exfiltration. That's where our project comes in. It's Stego. So, we actually put it up online at www.stego with a 0.com. So STGG, or what you got it, Stego.com, right? So what our tool does, data exfiltration and protection. It's a web-based HTTPS upload, so 443 standard port. The data that it gets uploaded is broken into data chunks, and each of those data chunks is encrypted prior to any Stego, and then the encrypted data chunk gets Stegoed into images that get scraped offline, and then those Stegoed images are placed out in the cloud. So no data is actually stored on the server. The server we're using is mainly an algorithm to perform the Stego. The benefits of this new technology, of course, the data exfiltration to remote system via standard port 443, port 80. Most intrusion protection systems, things like that, aren't going to block that for exfiltration. The encrypted contents to prevent others from accessing data. Like I said, the entire data chunks are encrypted using your choice of AES 128 or 256, and the Stegoed contents or Stegoed placed in images to prevent others from finding the data. And lastly, they're put out in the cloud, so that provides some sort of reasonable or plausible deniability, because you don't have any of that data on your system. It's stored out there in the cloud, and like I said, there's nothing stored locally, so that provides plausible deniability. The architecture of our tool. So our main concern was providing, of course, a CIA triangle. We wanted to have confidentiality, integrity, and availability of your porn, or in this case, your data, right? And so this is what I mentioned before. You could upload any type of binary file. It could be, a video. It could be a zip file. You could do encryption and compression prior to uploading it. So if you don't trust our encryption or anything like that, you could use your own algorithm, encrypt it, upload it, and that file will get broken up into data chunks. And then each of these data chunks are, we create a hash to, for more of the data integrity to validate when we retrieve that the data hasn't been altered in any way. So we create a hash of the data chunks and the entire data file. So when we put Humpty back together and all those chunks come together, we could verify that, yes, this is the file that got uploaded and nothing's changed. And this is a small piece of the algorithm that just does some of the chunking. So if you're doing encryption, it actually adds a little bit of padding to the file size. So it's just an arbitrary value. We, minimize the size of those chunks so it doesn't, add too much data into the Stegoed image, because it'll start messing up the resolution of the image. And then here is part of the checking of the chunks. So we have the hash before and the hash after, and we could simply compare those and say, yes, this data is valid. It hasn't been messed with. This is part of the code for actually checking the chunks. So when you retrieve it, it's pretty simple, straightforward. You have your hash before, your hash after. Check it, no problem. The encryption, every piece of data is encrypted. If you don't want to use AES encryption, we use simple PHP encryption to encrypt and decrypt, but you have the option of using AES 128 or 256 encryption. And like I said, that's to provide data confidentiality. And here's a little example of the encryption, pretty straightforward, nothing too complicated. Again, decrypting it, kind of just the reverse of the algorithm, nothing too crazy, depending on what kind of algorithm you're using to decrypt it. And different steganography. So when we're looking at the actual steganography part, there's lots of different techniques that you could use for steganography. Some are much better than others. You could store data in the comment field of an image, which is really lame and not really steganography. You could use the unused color space. So if you have a 32-bit color, most of the time you only use 24-bit, and you could use those unused bits. Or you could use the alpha channel for transparency. Usually there's about 7 bits of data there that you use per pixel within the alpha channel. This technique is actually really cool. It's called pixel value differencing. Now what it basically does is you have, within the primary color, you'll have 3 pixels, and it'll take 2 pixels, and it'll have an algorithm that determines between those two pixels if it's even or odd, and that's a symbolic representation of your binary data. So it's a proprietary algorithm. It'll take two pixels and say, okay, these two pixels, this is an odd, or this is even. And with that, you could symbolically represent binary data without it actually being in an image. So we take this kind of technique, and next slide, if you want to show what we do, is actually use the primary colors. Each primary color you have about, I guess, 3 bits that you could use for each pixel. So if you have red, green, blue, representing, by 255, 255, 255, whatever. So if it's even, let's say it's 0. If it's odd, it's 1. It's a symbolic representation of that data. So the data is not actually stored within the image. It's symbolically represented by the pixels. Does that make sense? Anybody have questions on that? So, okay, next slide. The advantage of this method, like I said, is that the data is not actually stored there. It's just symbolically represented within the pixel data. So there's no actual way of knowing if the image is actually stegoed or if that's the way the image was originally. Because there's no actual changing of the binary data. It's just taking the symbolic binary data and representing it. And we were able to get about 175 kilobytes from 800 by 600 pixel image with compression. So the Stego algorithm, it's pretty simple. We scrape, of course, images offline. We put them, see what we're doing here. Yeah, we put them in this function that I created, Stego put. So it takes your data file, your image, your key, and then puts it in a Stego file. You can look at the slides later. Destegoing, again, is just a simple function. It takes the URL that's encrypted, decrypts it, takes the key, and then takes a path and retrieves your image. So we're going to do a little demo of this application so y'all could get an idea of what it's actually doing. I'm going to walk through it. Yeah, that wasn't really my concern. So I'm scraping off IMDb. I'm not sure if I'm violating any end-user license agreements, whatever the publicly available images, so I'm scraping them offline and then placing them on Image Shack. So I don't know legal ramifications. That's, I don't know. It's yeah. Why not? Oh, it's just I don't think I'm violating their ELU. I'm just taking images that they have publicly available online. So I'm not trying to sell it. Well, maybe.
Yeah, you're absolutely right? We needed a large repository that had a lot of images in high definition, and this tool isn't really a public tool per se. This is educational purposes. Yeah, and so that is one of the improvements that we've been looking at, and we'll talk about this in a little bit. We actually have a section on this in the presentation, but you're absolutely right. IMDb was kind of our first shot at this, and we just wanted we wanted stuff that we could pull down, and then the kind of what Orlando had shown before, the size of the image, the number of pixels, determines how much data we can store within that. And so these images that you pull off IMDb, they're pretty large images. And one of the things we found is, especially with high definition movies, the files are very big, which means we can store a lot of space in there. Okay, so here's the example. You can see us logging into Stego. I'll kind of talk us through this guy. See if I can make it bigger. Bam. Yeah, so this is Stego. You can see we're logging in, username tasks. Here's our Stego application. We go to the Stego page. We provide a name for this particular project. In this case, it's passwords. You can give it a movie name, and this is what it's going to use to scrape that random data we talked about. You can provide a key to Stego the data. That's your password. Choose your encryption type. In this case, I chose AES 128, and there's a flag for verbose or non-verbose output. We'll talk about that in a sec. We give it the password, or my file, and very, very quickly we download our images. In this case, Princess Bride. That's my favorite movie. What Stego actually does is it grabs 40 images at a time, so that you don't have to keep going back to grab more. So it grabs a whole bunch of them. Then we Stego it in there, we AES encrypted it, we chunked it out, we embedded it in the image, and there we go. So that image was actually uploaded to Image Shack when I did this, of course. I'm going to go and show you, there's the Image Shack URL, we pop it in there, and there it is. Now, can you tell that movie had anything in it? Probably not, right? There's, you can't tell in there. So now we're going to go ahead and destego it. To do this, we need the key. and we need to select our project. Stego keeps track of the project. It's basically, it knows the URL we stored it at. We can choose again verbose or non-verbose. We can toggle the visibility of the project. We give it a password, and very quickly we click on Get Project File, Open With, and there it is. There's my passwords. You like that?
Yeah, so we're going to show a larger file now, because that was a small file,
No.
20
Yeah, that was a small text file. It had 3 usernames and passwords in there. Let me grab.
The file could be anything. It could be something in a script, it could be a movie, I mean, if you want to upload Apocalypto or some, you know, anything.
Okay, so in this example, we're going to take an unencrypted image, so just a normal image file. We're going to go ahead and run the Stego on this guy. Make this bigger. So very similar. We basically give it a name, Tiger Team. We give it a movie title, in this case Goonies. Provide the key. This one's no encryption. The bigger the file, encryption will obviously make it bigger. So if we say no encryption, it'll run faster and choose less images. Verbose output in this case, we selected the image. We go ahead and hit submit. I've cut the time down on this guy because otherwise it'll take a very long time. Not very long, a couple minutes or so. So now it's going out, grabbing a whole bunch of images, and you can see it's going to do multiple images this time because I have a larger file. It's an image file. So it's going to go down to multiple images, input our image into those. We have some time-lapse videography here. Bam, bam. Scroll all the way down, you can see all the images. Sometimes it grabs an image that's not able to use, so it ditches that. Other times, different images out there. So our one file ended up getting chunked into multiple images. In this case, there's 28 chunks. So now we go back to our dstego page. We have a new project in here now. Provide my super secret password. There's our target team project. Hit submit. It's actually going to go through and grab each of those chunks out of Image Shack. It's going to reassemble the chunks, decrypt, click on Get Project File, and now we can open our image. This is Chris Nickerson had an old TV show that was Tiger Team. Definitely recommend checking it out. That image is from that show. So that is Stego. You're getting ahead of us, man. This is awesome. Yeah, no. To answer your question, you're absolutely right? In this particular demo, we're only using one image repository. So if that image repository, say, all of a sudden decides to add a watermark in every single one of those images, bam, our data is gone, right? There's no way to reassemble that. So, yes, what we've talked about doing, and this is probably a future improvement to Stego if we choose to go that route, is we can actually we can use multiple image repositories and then use it just like that, right? You can say, I can upload multiple pieces, kind of in like a RAID 0 type of thing. So you have upload it to one image repository, upload it to another, upload it to another. And now if I go to this one and the piece isn't there, that's all right. I just go to this other one, right? So you have multiple locations. We'll talk about that stuff in a sec here. So full disclosures and caveats. You beat me to some of these. File types test their work. So we haven't tested everything. Like Orlando said, all binary data should work. We've tested text files, zips, MIDIs, different types of images. All of them work without a problem. So in theory, pretty much anything that you throw at should be able to function. AES 256 encryption. So we had some issues verifying the integrity of the data chunk, and so the program stops processing when it's unable to verify the integrity. This doesn't always happen. It only happens in some circumstances. So we're considering that experimental. Images. So, like you said, the images come from a public image repository. and there's lots of issues that come from that, right? Legal issues aside. If I have a repository of images, and I can go back and identify that original image, I can make a comparison between that original image and the image that I've stegoed, and now I have that diff. And so this is actually code that I found on that website where it actually shows, here's the original one, here's the modified one, and it actually does this diff using basically the algorithm that Orlando had used with the storing a bit per pixel in the RGB value, and it actually does that diff and then outputs the diff. Yeah.
So,
One comment on this. So I actually tried to do this to see if I could like break my own application. When you do diff it, if you have the original image and you have the other one, it doesn't give you any usable data because that data is encrypted. So what you end up getting is just a big blob of like black, just an image with black on it. And I tried different images and different stuff. And if you were to get any usable data, that data is encrypted and it's just a chunk of that data. And one caveat to circumvent this whole thing is if we just were to take the original images, which we scrape, and add a random digital watermark so it wasn't like the original, there would be no way of finding an original image to compare it to. So that's kind of a, moot point.
And we mentioned this earlier, but you want to be able to fit the most size in that particular image file that we're doing. So high def images, like what you find with Pixar, Disney, etc., we found are the best images to use because you can fit the most data there. So unencrypted data. The upload is encrypted, right? It's HTTPS. The chunks are encrypted, but the file exists on the server unencrypted for a very short period of time, right? You hit browse, you select the file, it's going up, it's going into some sort of temporary space. Theoretically, if somebody were to get access to the server, whether it's by subpoena or whatever, and that temp space weren't flushed out, they were able to get on the file system, actually look at the data, there might be data there for them to find. We've never tested that, but in theory, you should be able to do that. SSL. So our application only uses a snake oil cert, and we could probably prepare a whole presentation on why that sucks and why you can man the middle of that. So be aware of that if you want to play with it. CAPTCHAs. So we have a CAPTCHA. It works fantastic in Firefox if you're playing with it. It works in IE. There's some weird options that you have to select from the dialog box. If you're playing with it, I'd suggest Firefox. File upload size. So we actually limited the file upload size on this particular application to 102,400 bytes. If you need to do more than that, write the application. You can do it. Yeah, that's our choice. Yeah, that would be bad. Caching. So page and image caching is very popular these days to speed up website performance, right? We see all sorts of companies out there like Akamai and Squid proxies and things like that. So theoretically, Stego pages or images could be cached locally or on these proxy servers, which means that there's a copy of that image that you just viewed available on that system. So you no longer have that plausible deniability, right? Law enforcement could subpoena the results of that proxy, find it on the proxy server, and you're screwed. Also locally, a lot of times browsers will cache images for a certain period of time. So if you want plausible deniability, clear your caches, don't use proxies. Yeah, so there's actually, I mentioned when we were going through the demo, there's the verbose, non-verbose flag. This is the reason why we have that. If you use verbose output, it's going to output the copies of the images, the little thumbnails in there. If you don't use verbose, it's not going to do that. The reason why we do that is because if you have it on verbose, then caches can cache those images. If you don't, all it is text output, and that shouldn't get cached. All right. And like we said, there's room for improvement in this tool. Absolutely, there's no doubt about that. This was kind of a side project for both Orlando and I, and we talked about this, Stego mirroring. So this was kind of an idea that we came up with. How would you do replication? How would you handle the scenario where an image repository went and watermarked everything and wiped your data? And so we came up with Stego mirroring. No mirroring is a single Stego repository. Like a level 1 mirroring would be Stego images in 2 different repositories, and you could go up to mirroring plus whatever number you want, right? I could have 10 image repositories for 10x redundancy. We haven't implemented that, but if you were to go and write this application, very easy to do, you can definitely implement that. Bigger files. So the bigger files you have, the more data you're able to store, right? With an image, we're only able to store a certain amount of data. But if we go up to an MP3, that's a 3 meg file, right? You can store more stuff in that. If you go up to like an MPEG file or something like that, that could be hundreds of megs, right? So we came up with this idea, you could use something like SoundCloud as a repository and throw MP3s out there, or YouTube as a repository and throw movie files out there. Granted, if they do a manipulation of the data, you're kind of hosed, but if it maintains the integrity of that data, if it doesn't do weird compression, things like that, then you should be able to do that. So cache kills, we should probably add a no cache and HTTP expires headers. We kind of talked about that under the proxy stuff. These are just simple page tags that we could have added that would have told proxies not to cache this. All right, back to the future. So I started doing some digging on this, and it turns out that other people have had very similar ideas to this. It hasn't been implemented quite in the same way that we did, but these guys actually described an entire file system that was based on steganography. And it was complete with how do you do inodes and how do you do different directories and all sorts of stuff. And this wasn't from too long ago, 2007, but this was a convert file system layout embedded within Flickr photos, and this is the local view of when the file system's actually mounted. So this is something other people have actually put to pretty cool use and seen this. And this project actually turned into this project, which is PixSF, which is the Privacy Enhanced Image-Based Collaborative File System. This is slightly newer. And so they've actually taken this, and they do automatic image selection from video. They use a Tor node to actually route traffic through different nodes to protect the users. And then they have this covert FS on top of Fuse. So it still uses the Flickr stuff, but now it routes it all through these Tor nodes. So you have, one proxy, one point on the network doesn't get all the information, and then back here you're able to actually reassemble the entire file system.
One reason they have students because they have software on their client machine, whereas ours is web-based and
Yep.
there's no software. And that's where our tool's a little different. Is we have that plausible deniability. There's no
Right.
encryption software, there's no steganography software. Whereas these other applications get that can install software on your system or have an algorithm.
Yeah, and that's the case with all the ones that Orlando talked about before with the Stego plus encryption. Those are all things that you have to install on your operating system, have on your system, and then we get back to the conundrum that we had with encryption, which is if it exists on your system, then you're probably using that for something, to hide something, and now people are going to start digging, right? So we wanted to get away from that. With Stego, there's nothing sitting on your system. It uses HTTP callouts. There's literally nothing there for somebody to find. All right, so in closing, this is proof of concept. This isn't a production application. You can try it. Orlando gave you the URL, but this is for educational purposes only, right? We're not responsible if you use or misuse this tool, right? I don't care what data you put up there. Eventually it's getting thrown into an image and put on somebody else's server. We're not collecting any contents. We're not keeping any contents, but you can play with it, right? It's educational. All comments and opinions are the property of the individuals, the two of us. Again, they don't represent our employers or anything like that. And all content is provided as is, no warranties, assurances, or guarantees, right? We work pretty hard on this. I checked it for application vulnerabilities. Orlando did a lot of coding on it. But there's issues, there's bugs, right? There's bound to be something. So use at your own risk.
I just want to kind of talk about where I see this kind of going and what I wanted to do with this project. I mean, it's cool to have a web-based application, but what I wanted to try to do with this is use it for data exfiltration and I guess circumventing IDS and intrusion protection systems. So I wanted to try to see if I could make an API and make a Metasploit module where I could use this to get my data from the cloud on a victim machine, getting binaries, executable, whatever, through a standard port and, circumventing all the intrusion protection systems that might be on the system. So I think that might be another way to go with this Stego encryption technique is, maybe a Metasploit module or something like that to use this. So that's interesting. Anyhow, questions? Yes. I haven't tested. No, I had some, the last conferences, I had some people that did steganography research, and they were telling me that this technique wouldn't be, I guess, recognized by Encase and other tools like that their steganography software wouldn't pick up on this technique of symbolic representation of the data. Not so much as but the technique that's used is a symbolic representation of binary data. There's no actual data there to compare against. So anything would just look like an image.
It's RGB,
Right.
right? So there's 3 bits, and seeing all the RGB represents the color value.
So, you know, unless if they have the original image to compare it to, there's no way to tell just based on the RGB value that there's data in there. If that makes sense. Yeah. Other questions? Yes. Yes. Yes, you're absolutely right. They're again, educational, proof of concept, right? So we're not looking at this as, go ahead and upload your prawn to this system. We're looking at this as, this is a really cool thing, something that we were playing with, and it works very, very well. But absolutely, there are lots and lots of scenarios that exist where, like we were talking about, where somebody can look through cache and find that stuff, and headers is just another thing, right? Web logs, things like that. All that stuff is there. If you would actually set up a system that you wanted to I guess, be confidential so that nobody could find it, there's a lot more work to be done there. Yes. Yeah, that's a great point. Anybody else? No? Yes? No comment. All right. Cool. Thank you, guys.
Should have sat in front of my computer.
That went pretty well, man.
Yeah.
Good job, guys.
A lot better at talking.
Had a little experience.
Yeah.